Yeah, so we are going to start off this machining project where we're going to be doing a lot of 5-axis machining, predominantly indexed machining, but with some continuous as well on this fairly complicated looking part, which on cursory inspection looks like something that'll work just fine with 3-axis, but when you focus a little bit more closely, you'll see there's quite a few parts on this that really do benefit from the extra freedom that a 5-axis machine offers. So to start with, we're going to go through a few roughing operations. So I am going to grab a new group to start with, which we're going to call roughing. Actually, no, we're going to call this vertical machining because that's all we're going to be doing in this. So let's go with vertical for now. May rename that later on, not sure, but for now it seems good. And at the very least, no, you know what? Let's call this vertical machining just to deal with any future confusion, because there's always confusion further down the line. So for now, we're going to go with a roughing waterline just to get as much of the material out of the way as possible. And we're going to be using our 20mm milling tool here. We are going to just leave the settings at default for the moment. So yeah, let's generate the toolpath and see what it does with that. So for now, yeah, that all looks pretty good. I'm probably going to want it to exceed the bottom a little bit because there'll always be a little bit of sort of just an onion skin's thickness of material left there, which if this is being machined out of metal makes horrible noises, and if it's being machined out of plastics it leaves things that can break. So let's go into strategy and just tweak this a little bit. So the bottom level is going to be 28mm, and we're going to turn on step up as well. I think we should probably also set the radial and axial stock at 2mm as well. And I'm going to loosen up the tolerance a little bit just to make it a little faster to calculate. And with that, I think we can generate that toolpath now. And we've probably got something that's worth simulating at this point. So let's take a look, shall we? So I'm going to speed this up a little bit because there's a fair bit for it to take off, and we don't want to be waiting here all day. So let's accelerate this a touch. It's not doing anything unexpected so far. We're generally seeing pretty good material removal there. A couple of little islands here and there, but they're getting trimmed back nicely. So that looks like a pretty good approximation of what we're aiming for at the moment. So let's take off some of that excess material from the outer edge, at the very least. So we're going to go with a 2D contouring operation, and we're going to grab that bottom contour, and by double clicking on it we can propagate that all the way around. We can also click on it once and then right click, and we've got options for different propagation methods. This is something that's I believe was introduced in ENCY 2. It's a really useful tool, so definitely worth looking into if you're dealing with more complex shapes. We are going to define that as our curve. We are going to also set this guy here as our top level, since with contouring you can actually use another contour to define a level. And we're going to set this guy down here as our bottom level. We're now going to quickly tweak that in strategy. So I'm going to actually set that at 112 and at 28, just so we've got that little bit of extra security to make sure there's no bits of swarf left over. And I'm going to define that as a helical machining pass. So by doing so, we should have, yeah, we've got a nice helical path there. So again, we're going to very quickly simulate that. It shouldn't take very long to run. Just a nice way of checking that we're cleaning up everything we need to clean up, which is ideal. Beyond that, we are going to want to take a look at trimming some of the excess off of the next feature we're going to be working on, which is going to be this top section here. So we're going to create another 2D contouring operation, and we're going to select this contour, and we're going to select this contour, and those are the curves we're going to be working to. I'm going to set this as the bottom level, and the top level is a little bit harder to do, but as we can see, it's already determined what the top of the remaining part is, so we don't actually need to do anything there. Beyond that, again, helical machining is generally a nice and time efficient way of doing this, and we are now going to generate the toolpath. And that looks good overall. I'm quite happy with that. That's a nice and clean setup. And the last thing that we're going to do, once we've simulated this, is we're actually going to go around the outer edge of this just to make sure that we get everything. So let's quickly simulate and just make sure, yep, nothing bad happens there. We'll verify compare so we can actually see that we've got the nice green there, which is what we need. Green basically means we've got it to tolerance. Now it's worth saying as well, just so you know for the rest of this project, that the tolerances measured in verify compare, as you can see, are actually pretty tight. We're talking 10 microns and 50 microns. This is not a production part, so I am not going to be dialing things right in to be mega precise on this. This is more about a demonstration of what the various techniques and methods that are available to you are, and to introduce you to the principles of 5-axis machining in ENCY. It's not a perfect how-to on achieving sort of aerospace grade finishing, okay? That's not an excuse, it's just, as I say, you've got to work out what it is that you're specifically aiming for with the training, and for me, it's showing you guys how to manipulate the components and the machine in order to achieve the effects you want. So we are now going to add one more 2D contour, and we are going to grab this contour and we're going to select tangent edges don't really want to be selected. That's interesting. Okay, they're being a bit fussy. That's fine. So what we can do is we can grab these edges here, and I'm going to turn off curves, and we're going to grab that edge there because there is actually a complete polyline curve left there from when I made the model, my mistake. We're going to define this as our curve to machine, and we're also going to define this as our bottom level. Generally that looks good, but I want to turn on helical machining again. So let's generate that, and we've got a very nice, quick, easy cleanup path there now. So if we simulate this, we can see that we get a very tidy path there, which gives us the bulk of the definition of our part quite readily. Now the last thing I'd like to do is I want to clean up this top surface. So let's look a little bit further afield than just 2D. Let's go to 3D entry. And we're going to grab a flatland operation here. And this is the surface we want to aim for. So let's, we are going to want to grab the edges around here, and we're going to set this as a restrict zone. And no, we're not. We're going to delete this, and we're going to set this as the face that we're working on. Sorry, it tries to auto select the entire part, and more often than not with a lot of operations, you'll typically find that you set restriction zones or job zones to specifically determine what it is that's going on. With flatland and other not quite 3D operations, typically you just need to grab the face. Because it tried to grab the entire part, i.e. multiple flat faces nearby, it's actually gone and split it into two operations, which is not really ideal for what we want. So I'm going to delete this first one, and I'm actually going to rename this one to number 1, just because that's going to bug me otherwise. And now that we've just selected that one face, we can click on Generate Toolpath. Now we've got a few options on how it approaches this. At the moment, we've got an equidistant path. I kind of want to see what HPC looks like, so let's click on that, and it's much the same. We can also do adaptive. We've got plenty of different options on this. Adaptive seems a little bit on the crazy side, so we can probably do deep HPC again. So again, as I say, we've got plenty of different options for this, some of which are completely ridiculous, some of which are absolutely spot on for what we need. But at the moment, just a simple HPC path works fine. Yeah, so we now simulate that, and we click on run. We can see that gives us a nice clean path to work to, which also means that we're not being hit too hard with anything else there. So in the next video, we're going to start taking a look at cleaning up some of the parts that require indexed motion to be able to get around. And from there on out, the techniques will get progressively more complex and involved, but will hopefully give you the best possible insights in how to use 5-axis machining within ENCY. We'll see you in the next one.